Alright, so we are having the third problem. The work function of potassium metal is 2.3 eV. What is the maximum wavelength of light that is needed to free an electron from the surface of the potassium metal? So you are already given with the eV. So what you need to do is to convert this first into joules, and you know that the conversion there is 1 eV is equal to 1.6 times 10 to the negative 19. 1 eV is equal to 1.6 times 10 to the negative 19 joules. So that means that 2.3 eV times 1 eV, 1.6 times 10 to the negative 19 joules is also equal to, in my calculation, I have 3.68 times 10 to the negative 19 joules. Alright, so with that, I need to determine the wavelength, the maximum wavelength that is needed to free the electron. So I understand that E is equal to HF, but I know also that C is equal to F lambda. So lambda F is equal to C over lambda. So that with that, I can have E is equal to H times C over lambda. Having this formula, I can have that lambda is also equal to HC over E. With that, I can have 6.63 times 10 to the negative 34 times the speed of light, which is 3 times 10 to the 8 meters per second, all over 3.68 times 10 to the negative 19. So the answer for the wavelength is equal to 5.40 times 10 to the negative 7 is also equal to 540 nanometer. Now, if light, that is already the wavelength that you need to free the electron. If the wavelength now is for 125, what will be the kinetic energy of the electron in eV? So what you can do right now is just the same. So KE is equal to the energy of the photon, which is hc over lambda minus the work function, which is equal to 3.68 times 10 to the negative 19. So that means that you can have 6.63 times 10 to the negative 34 times 3 times 10 to the 8 meters per second all over the wavelength, which is equal to 425 times 10 to the negative 9 minus 3.68 times 10 to the negative 19. So the answer here will be equal to 9.97 times 10 to the negative 20 joules. Now, the question is, what is the kinetic energy in eV? So all you need to do is just to convert it. So 1 eV is equal to 1.6 times 10 to the negative 19 joules. So the answer is 0.623 eV. This is the kinetic energy of the ejected electron, and there is another question: calculate the speed of this electron. With that, we can have, we need to use the energy in joules, not in eV. So because that's the SI unit for kinetic energy, so I will have V is equal to the square root of 2 KE over M. With that, I can have V, which is equal to 467,846.5 meters per second, or it's just going to be equal to 4.68 times 10 to the 5th meters per second, and that is the speed of the ejected electron.